All right, we are looking at domain and range of the square root function again today. So yesterday, hopefully we pulled out most of the information that we would need today, looking at it from a graphical, but also a equation standpoint, that we can get this information from the equation itself. Though for the most part, it's going to be off of graphs still. So some of the examples that you'll be given today will not give you the equation. It'll just give you the graph. Some of them will give a graph and an equation. Don't think any of them give you just an equation. Though, like I said just a second ago, it could, because of the information that we should be able to pull from it, though one or two examples may be at least a little bit different than what we're used to and kind of change how we look at a little bit of it. So the first equation that we're going to look at today is f of x equals negative 2 square root of x minus 3. And so this is something that we might have done yesterday. And so we get something that looks a little bit like this. So a few things that you might notice first from yesterday. I'm going to pull it over so we can actually see it. Right? Yesterday we were asking questions like, how is this different than the parent function f of x equals the square root of x, right? And so you would have said something like, well, it's flipped across the x-axis, might be a little bit more than you talked about, but it's flipped to the other side. It's wider, right? Just flipping it didn't quite do it. And then it's moved, well, it's moved, what, 3 units to the right. Or you could have said moved 3 or positive 3 horizontal units or something like that as well. And then, so that would have been one of the things we talked about yesterday, something you want to keep in mind. Hopefully you saw the connection between the movement of the parent function and the equation we're dealing with, right? So one of the things is that this equation is flipped, right? Well, what flipped it, right? What made it flip? What made it go from this positive function to this negative function on the other side of the x-axis? And hopefully you recognized that it's this, right? This negative flipped it, all right? And what made it wider? What made this open faster than this function, right? This function is narrower, it opens slower. What did that? Well, again, hopefully yesterday, as you worked on the project, you recognized that it was this 2 that did that. The 2 here is what makes it go quicker to open. That same kind of thing would have happened if we had like a 2 on the inside here, right? It's also going to open faster. That'll move it a little bit as well, right? But it does also change. Well, maybe it does just move it. Oh, I think I'm wrong on that one. If there's no minus 3. So this 2 on the outside makes it wider, right? If we had something like 0.5 instead, right, it gets narrower. So, well, what made the graph move? So it started at 0, 0 here. Why does it start at 3, 0 here? And hopefully you recognize that it's this here, right? Again, like a number of the other equations that we've had, like parabolas, right? Or trying to think, there was another one as well. Did it happen in absolute values maybe? You see that the x minus 3 actually moves it to the right 3, it moves it positive 3. If we had x minus or plus 3, it would move it to the left 3. And so hopefully that's something that you recognized. All of that helps play into our domain and range. All right, so for today, all you're doing is domain and range, but I want you to see those connections here, right? So what is our, if it'll let me put it in here, what is our domain? It's going to show up as nothing when I actually put it in, I think. The domain, right? What values of x can we put in? We don't care about the parent function anymore. What values of x can we put in? And the way it's always going to show up for, with the exception of ones that are very clearly the other way, the way it's always going to show up is in the notation form. So what is the smallest value of x that we can put in? Well, our equation, our graph of the function starts at 3, 0. The value there for x is 3. And the largest value we can get would be as big as the graph can go, right? And I don't know if I have, looks like I don't in here. Okay, so if I were doing it somewhere else, I could. So I'm going to use 0, 0 as my infinity sign, right? We're going off to infinity. Infinity is not a real number, so we close it off like such, right? So again, 0, 0 is going to be my infinity. In the program that you're using, it will let you actually use infinity. There'll be a button for it. If not, 0, 0 is sometimes how you would do it if it's not there. How about our range here, right? Range again is what values of y are we allowed to use? So, or can we get, right, out of the function? And so look here, can we get a positive 1? Is there anywhere on this graph of the square root where we get a positive 1 value out? And you might think, well, if we zoom out far enough, but you'll notice that as we zoom out farther, the square root just continues to get smaller. And so it does appear that it's never going to cross this x-axis, right? And so what is our range? What's the smallest, or here, what's the largest value of y can we get, right? And that is, oops, wrong button, that is 0, right? We can't get 1, we can get 0. And what's the smallest we can get? Well, like I said, it looked like it went on forever negatively, right? Oops. And so that's a negative infinity, right? It goes on indefinitely down, right? Most of the problems, this is the way that you're going to give your answer. So just to give an idea there, right? Okay, so again, notice where these things come in, right? There is no shift. There's no shift on the y-axis, right? That's why we're starting at 0. And we have a -3 here. That's why the domain starts at a +3, right? It's going to negative infinity. It looks like a -0, negative infinity, because of this negative out front, right? In our domain and range, this 2 doesn't matter. Okay, good. Let's look at a different function. I'm going to leave my domain and range written just so I don't have to rewrite it all every time. 4 minus the square root of 2 minus, oops, that's the one I just did. No, it's not. 2 minus x. That is absolutely not. And my caps lock on. I don't want a slider or a blank. All right. This looks better. All right. So again, even though it's not questions that you'll have to answer, it is good to recognize how is this different? How is this different than our parent function? Well, our parent function looks like this. Right? So again, this graph looks like it is flipped upside down, right? Think if you were to, like, I don't know, pour water into this, right, it would run downhill. Whereas if you, and along the curve, whereas this would be on the outside of the curve, right? So these are flipped of each other, right? That's this minus here, right? How far is this shifted away? Well, it's 2 to the positive and up 4, right? This is a little bit weird, right? This is different than what we've looked at. So the 4 is this. Yesterday, if I'd asked this question, right, I would have put the 4 there, right, after, but it doesn't matter where it goes because addition is commutative, so it can be in either spot, right? So it's up 4, this is our shift up 4, or you might have called it a positive vertical movement of 2 units, right? This flips the graph upside down. And then we have 2 minus x. 2 minus x. Well, we still have 2 and a minus, even though the 2 and the minus are switched here, right? The last problem we would have had like x minus 2 rather than 2 minus x. But really what we're looking at here is what makes, excuse me, I'm gonna sneeze. What makes under the square root 0, right? It's when we plug in a positive 2, right? So that's why we still move 2 to the positive. And so that will help us with our domain and range. Okay, so the first question again, domain. Again, we don't care about that function anymore. I'll keep bringing it back. The domain, the first question we ask is what's the smallest, what's the largest values in the domain we can get? And actually I could have deleted this because it is not super helpful for us, right? So here, if we look at our graph, what's the smallest value of x? I can keep zooming out and it's gonna keep going and going and going forever, right? So in this one, the lowest number I can put in is negative infinity, right? I can put in any negative number of x and it will work. Now you might ask yourself, but aren't we under the square root? How can we put in negative numbers under the square root? But you'll see that we have 2 minus x, right? 2 minus x, which means any negative number that we put in is actually going to be addition, right? So if I'm putting in negative 10, I have 2 minus a negative 10, that's 2 plus 10. And I can take the square root of a positive 12, right? Well, what's the biggest number that I can put in for x? Well, we follow the graph up, and it's this value here. The x value at this point is 2, right? The biggest I can go is 2. Can I use 2? Did it again. Can I use 2? Yes. So that's what, again, what this notation does. The open parenthesis here means that you can't actually use negative infinity. You can't use negative infinity because it's not a real number, not a number, right? It's not like 4 where you can count it. You can count 4 things, right? You can count 10,000 things. Take a long time, but you can do it, right? You can't count an infinite number of things, right? That would defeat its purpose of being infinite, right? To be infinite means you can't count it. So you have negative infinity, we can't include that, so we use an open parentheses. The 2, on the other hand, right, we can put in a 2, it gives us 2 minus 2, which is 0, and f of x would be 4 at that point. If you tried to put in 3, right, 2 minus 3 is negative 1, and the square root of negative 1 is an imaginary number, and we can't use imaginary numbers, right? Okay, so how about our range? What's our range? Well, what's the smallest number we can get? Again, we can kind of zoom out here and notice that the function always is decreasing. And if the function is always decreasing to the left, that means that we again have negative infinity as our lower number. What's the highest value of y that we can get? Well, if we follow it along here, it comes up to here and stops. This is the point 2, 4, 4 being the y value. That's the upper limit of the range. Now, can we get 4? Well, we just talked about it, right? If I put in 2 for x, I get 4 minus 0, which is 4. So yes, I can actually put in that point. The bracket means that I am including the point 4. 4 is a point that I can use, right? So domain and range. And we'll look at one more function here. How about a negative square root of a negative x minus 3 plus 2? So then how is this different than our parent function? At least for the parent function, hopefully you have it at least semi-memorized, right? It starts at 0, 0, comes through the point 1, 1, and then it starts growing slower, right? So it looks something like that. At 4, we'd be at 2, right? So something in that range, right? Does this function look like it's growing faster or slower? Well, if we go 1 away, right, then we've come down 1 over 1. And if we go 4 away, we've gone down 4 over 4. So this looks like it's the same function, just rotated, right? And flipped, right? So why is it flipped? It's flipped because of this negative here, right? So that's what turns it upside down. We've talked about that, right? You'll notice that it is up 2 units, up 1, 2 units. And this one might feel a little weird. It's minus 3 here, but we have moved to the left 3. And hopefully you can recognize why that would happen. It's because we actually have a negative x minus 3, so they're both negative, which makes this a little bit different. You could think of this as a negative x plus 3, right? If we had parentheses here, we could call this negative x plus 3, and that changes how this is going to work, right? This is why it's helpful to look at the graph, even if you kind of have an idea of what's going to be happening, is because there are little things that can change the graph to make it not quite what we would expect. All right, but all of the ones that you have, I believe, give you the graph, and so we can look at it. All right, domain. What is the smallest value in the domain we can use? Well, again, it looks like it goes off to the left forever. That's negative infinity. What's the largest number in the domain? Largest number in the domain is negative 3. Again, that helps to describe our shift as well, right? If we have a negative 3, minus 3, that's 3 minus 3, which is 0. And again, that shows us our shift, right? What about for our range? We are definitely going down again, negative infinity to, well, the largest number we can get out of this is that positive 2. Notice how that relates to the y value, the y shift. All right. All that you're doing today is relating to domain and range like this. Again, for most of the problems, you are going to be writing them in this form, where an open parenthesis means you're not going to include it. For today, that's any time that there's an infinity or a negative infinity, you're going to use an open parenthesis. That's not generally going to work, but for today's, that's going to work. Like if we were working in an inequality, then it changes a little bit, not with the negative infinity, but the other side of it might change. So again, we can, what did I say? If you're dealing with infinity or negative infinity, then you want the open parentheses. And if you're dealing with an actual number to negative 3, you're using a bracket, right? The last thing then for this, there's something else I wanted to add with that. your domain has to go or should go in order. So the smaller number goes first and then the bigger number. Negative infinity is much, much smaller than -3. Negative infinity is much, much smaller than 2. However, if we're going to infinity, then it's the number and then infinity, right? Infinity is the biggest number you can get. Negative infinity is the smallest number you can get. And again, I think that's it. If you have any other questions on any of this, feel free to set up an appointment with me and we can talk about it then. Domain and range, and I can try to explain it differently if this doesn't quite fit for you, or at least have it where we can have some back and forth, and I can try to figure out if you have any misunderstandings about domain and range in this kind of function. But most of the problems should be like this. Oh, there was one other thing, sorry. There is at least 1 or 2 problems in the homework today where it'll go and give you a function like this, but then it won't continue, like it'll stop at -7, right? Like there'll be a closed point here at -7, the rest of the graph won't be there, right? In that case, right, if we were looking at the same problem, but it ended here, right? It ended here. Then your domain would be -3 to -7. Sorry, -7 to -3. And you would include the -7, right? And then we would go from what's the lowest number we could have. There it would be 0 to 0 being the lowest y value at -7, and 2 being the highest up here at -3. Right? So that problem does come up as well. Again, if you have questions on any of it, make sure you ask. There is 1 or 2 questions that also use the less than or equal to, greater than or equal to notation as well, which I showed both examples yesterday.